All right, guys, so in this section, we're going to talk about a different method for solving linear systems. The first method we learned was graphing, and that's a process where we graph both lines on the same grid, try to guess where they intersect, and then plug that point back into both equations to make sure it works. Okay, and obviously that process had its issues because it's a little bit tedious, but here is a method that I think is a little bit more concise, and it's called substitution. So I'll quickly go through the steps, but I think the best way to learn this is by just seeing a few examples. So the first step is this. When necessary, you're going to pick one equation to isolate one of the variables. You got two different equations to choose from, and you're going to isolate one of the variables. You're going to have four options every single time. You can pick really whatever variable you want, but variables that have a coefficient of 1 are usually good choices. Okay, you're going to substitute this variable into the other equation. This will isolate the variable, substitute again, and then you ultimately solve for your x and your y coordinate. Okay, so let's just do an example. So it says solve the linear system, and I'm giving you two different equations. I'm giving you negative x plus y is equal to 1, and I'm also giving you 2x plus y is equal to negative 2. Okay, so the first step if we want to solve an equation or a system using substitution is to pick one of our four variables to isolate. Okay, whenever you're doing linear systems in this class, you're going to have four different options to choose from in terms of a variable you want to isolate. So what are your options? You could choose to isolate this x, this y, or you could isolate this x, or you could isolate this y. Okay, you're going to have four options every single time. And it doesn't really matter which one you pick, but sometimes there are variables that are easier to isolate than others. Okay, so typically you want to aim for variables with a coefficient of 1. Okay, so what I'm going to do is out of these four options, the variable I'm going to pick to isolate is I'm going to pick to isolate this y in the first equation. Okay, I think it's decently easy. It's only one step to isolate it. If I want to get y all by itself, all I need to do is I need to add x to both sides. And when I do that, I'm left with y is equal to x plus 1, and y is all by itself. I have one variable that's isolated. Okay, so the first step is to get one of your four variables all by itself. Pick the easiest one if you can. Okay, so the first step, I isolated this y. Now what I'm going to do is I'm going to substitute this value in for y into my second equation. Okay, so what does that mean? Now, I know that y is the exact same thing as x plus 1. So what I can do now is wherever I see a y in the second equation, I can plug in a x plus 1. So watch how I do this. I'm going to rewrite the second equation by substituting x plus 1 for y. So I'm going to rewrite, I still have a 2x, I still have a plus, but instead of writing y, I know that the exact same thing of y is x plus 1. So I'll rewrite y as x plus 1. And this is still equal to negative 2. Okay, now what I'm going to do is I'm going to solve for x using the rewritten equation. So I have 2x plus 1 is equal to negative 2. 2x plus x is equal to 3x. I still got a plus 1 on the left is equal to negative 2. Then I subtract 1 from both sides to solve for x. 3x is equal to negative 3. Divide both sides by 3. And I should get x equals negative 1 as my first answer. Okay, so to recap, I solve for one of my variables. I know that y is the exact same thing as x plus 1. Then I substituted x plus 1 in for y in the second equation, and I solved for x. Okay, so I've solved for one of my variables. Now I need to solve for the other. So I know that x is the exact same thing as negative 1. And what I'm going to do now is I'm going to plug in, I could pick either equation that I want here. I could pick the first or I could pick the second. I'm going to plug in negative 1 for x to solve for y. So you could pick either equation you want here. I'll just pick the second one because I like it a little bit more. And now I'm going to solve for y. So I'm going to substitute -1 in for x. So I'll still have 2, and then instead of writing x, I'll write -1 plus y is equal to -2. And this time I'm going to solve for y. 2 times -1 is -2. -2 plus y equals -2. Add 2 to both sides. And I should get y is equal to 0 for my y coordinate. Okay, I have 2 different numbers for my answers, and it's probably a good idea to plug both these numbers back into your original equations to make sure they make sense. Okay, so if I plug in -1 in for x into the first equation, I'll have -1 plus y, which is plus 0, equals 1. Negative becomes a positive. Does 1 plus 0 equal 1? Yes, it does. And then plug it into the second just to make sure. 2 times -1, x is the same thing as -1, y is equal to 0, plus 0 equals -2. Does -2 plus 0 equal -2? Yes, it does. So I know these two values are correct, and I could write my answer as an ordered pair, -1, comma 0. Okay, let's do another one. So if we do example A, once again, I have 4 different options to get a variable by itself. I could choose to get this x by itself, this y by itself, or I could choose this x, or I could choose this y. Okay. Out of these 4 options, I feel like the easiest variable to get by itself would be this x right here. It's got a leading coefficient of 1. Okay, so I'll take x minus 4y is equal to -1, and my first step is to get this x all by itself. So I add 4y to both sides, and I know that x is equal to 4y minus 1. Okay, x is all by itself. I know that x is the exact same thing as 4y minus 1. So now what I'll do is I'll jump to the equation that I have not touched yet. 2x plus 2y equals 3. And wherever I see an x in that first equation, I'm going to plug in 4y minus 1. So I'll still have a 2, but instead of writing x, I'm going to substitute in 4y minus 1 plus 2y is equal to 3. And this time I'll solve for y. So first thing I'll do here is I'll distribute. 2 times 4y is 8y. 2 times -1 is minus 2. Still got a plus 2y equals 3. Simplify this a little bit. If I start with 8y's and I add 2y's, I should have 10y minus 2 equals 3. Add 2 to both sides. 10y equals 5. Divide both sides by 10. And I should get y is equal to 1/2. Okay. So I know that y is the exact same thing as 1/2, and now I have to solve for x. So I go back to my original equation. Did not mean to do that. So I go back to one of my original equations, and wherever I see a y, I'm going to plug in a 1/2. So I'll just pick the first one, or the second one rather, because I think it's a little bit easier. To solve for x, I'll have x minus 4 times 1/2, plug in 1/2 for y, is equal to -1, and then solve for x. 4 times 1/2 is 2. X minus 2 is equal to -1. To solve for x, add 2 to both sides, and you should get x is equal to 1 as your answer. If you plug these numbers back into the original equations, they should spit out true statements. But what is our answer here? It's the coordinate 1, 1/2.